Hello everyone, my name is Saurabh Singh and today I'm going to teach you about the compaction theory, which is from unit 2nd, and this is my lecture number 14. After watching this video, if you have any doubt, you can contact on this number which is given here, and you can also write an email on saurabh.singh@mygyanvihar.com. So let's come on the learning objective and learning outcome. Here I will provide you to knowledge of clay mineralogy and the compaction of soil, and to involve application of scientific and technical principle of planning and analysis, design of foundation along with the soil improvement techniques. And you will get diverse knowledge about the geotechnical engineering practices applied to the real life problem designing of a structure. The student will learn to understand the theoretical and practical aspect of geotechnical engineering along with the design and management application. So come on our topic, which is known as the compaction method. And first we will see the compaction. As we all know, we have done this topic. As we all know, compaction is the process of removal of air voids from the soil sample. And as you can see, soil is used as a basic material for the construction. Maybe it is a retaining wall, maybe it is highway embankment or ramp, maybe it can be airport. And the advantage of there is also advantage of using soil. That's why we all time use soil in the construction of this kind of a structure. First one is in generally available everywhere. It is easily available everywhere. It is durable. It will last for a long time, has comparatively low cost, and you can also, if you want to purchase the soil, you can also get it in very low cost. That's why soil is easily available everywhere. Now we will see what is the compaction. In most instances of civil engineering and construction practices, whenever soil is imparted or excavated and reapplied, they are compacted. The term compaction and consolidation may be sound as though they describe the same thing, but in reality they do not. What is the compaction? As you can see, what do you think about the live compaction machine? It is just, as you can see, there is one image of elephant. It is also working as a compactor because just because of its heavy load. When loose soil are applied to construction site, compressive mechanical energy is applied to soil using special equipment to densify the soil or reduce the void ratio. Typically applies to soil that are being applied or reapplied to the site. And what is the consolidation? We will also see when static load are applied to saturated soil and over a period of time increased stress are transferred to the soil skeleton, leading a reduction in void ratio. Depending on the permeability of soil and magnitude of drainage distance, this can be very time of consuming process. Typically applies to the existing undistributed soil deposit that has been appreciable amount of clay. As you can see here, consolidation is the process of removal water voids by the using of static load, and it will also reduce the permeability of a soil, and it will also a very long, like if you will do the consolidation of any soil, it will take the lot of time. Now we will see here what is the difference between compaction and consolidation. As I told you, in consolidation, it is the meaning. Consolidation means that removal of water-filled porosity, and compaction means removal of air-filled porosity. And simply, you can also say the consolidation is the process of removal air voids, and compaction is the process of removal air voids. Sorry, in compaction we need to remove the water voids. In consolidation we need to remove only water voids. We do not need to remove the air voids in the consolidation. And compaction we can do instantly, but consolidation we cannot do this instantly because it is time taking process. Now we will see the principle of compaction. Compaction of a soil achieved by mechanical things and mechanical energy. It is assumed that the compaction process does not decrease the volume of the soil grain. As you can see here, this is the soil sample, and where is the uncompacted soil, and this is your compacted soil. Means there is less voids, and this is uncompacted soil in the rounded form, and this is your compacted soil, where you can see there is no gaps between the two solid particles. What is the main goal of the compaction? We will see here. This is your first diagram. As you can see, first one is the air, water, and solids, and there is a goal of compaction to reduce air voids volume VA in soil as much as possible. For given water content W, the maximum degree of compaction that can be achieved is when all of the air voids has been removed, that is, saturation will be equal to 1. Since, as we know, S will be equal to WGS upon E, the corresponding void ratio for S will be equal to 1, will be E is equal to, here E will become here WGS. Now we will see the principle of compaction. The degree of compaction of soil is measured by the dry unit weight of a length. The dry unit weight of soil will be the increase by the doing of the compaction. The more compacted soil, if you will see the more compacted soil, it has more dry density in compared to normal soil. The higher its dry unit weight, GD will be the higher. Now we will see how we calculate the gamma D, which is equal to bulk density of soil. Block diagram is showing first diagram. As you can see, there is air, water, and solids, and total mass will be represented by the M, and it will be MW plus MS. Means MW means mass of water plus mass of solid, and we do not need to take here mass of air because we assume as the zero. The mass of air we assume as a 0. Total volume will become here VW plus Vs, and void ratio will be E will be V upon Vs, which is volume of voids upon volume of solids, and water content here will be MW upon MS, and saturation, degree of saturation, will be represented by the VW plus VV. And this is the moist soil unit weight, which is represented by the gamma, will be equal to MW plus MS divided by total volume, and it will become W plus 1 MS upon V, which will be equal to 1 plus W gamma D. And gamma D here we can write as a gamma upon 1 plus W, and W will be the water content, and gamma D will become GSGW upon 1 plus E. E is here void ratio. So, what is the motive of the doing the compaction? By the compaction, we can increase the shear strength of a soil. This means the larger load can be applied to the compacted soil since they are typically stronger. And it also reduces the permeability. This is the inhabit soil ability to absorb water and therefore reduce the tendency of expand, shrink, and potentially liquefy. Reduce compressibility. It also reduces the compressibility. It also controls the swelling and shrinkage, and it's also reduce the liquefaction. As you can see, there is various compaction types test. As you can see here, there is types of test like mold, hammer, mass, drop, number of layer, blows as per layer. This is the table content of various types of compaction test, as you can see here. Now we will come on the general compaction method for the coarse grained soil and fine grained soil. Here one is the laboratory test and one is the field test. And in laboratory we have to use vibrating hammer, which is known as BS, and for fine grained soil we have to use the falling weight and hammer, kneading compactor, and static load and press. Here you can see in the field we have to use the hand operated vibrator plates, motorized vibrator roller, rubber tire equipment, free falling, compaction vibration, weight and dynamic frequency we can use, and hand operated temper we can also use for the field, uh, and seafood roller which is used in the compaction of soil, rubber tire roll, this is also used for the soil compaction, and standard proctor test. First we will see the standard proctor test, how we will conduct the standard proctor test. As you can see, R.R. Proctor in the early 90s was building dam for the old Bureau of Water Work and Supply in the Los Angeles, and he developed the principle of compaction in series of articles in engineering news record. And variables of compaction is here also. Proctor stabilized that the compaction is the function of four variable, as you can see here. First one is dry density, which is represented by the gamma D, or dry density unit weight, which will be represented by the uh, and gamma D also, and water content W, comparative efforts energy E, and soil type gradation, presence of clay and minerals. These are the variation which affect the compaction, and these are the, you can also say this is the compaction function for the variables. Now we will see the compaction proctor test here. Standard proctor test equipment. There is hammer which weight is 5.5 lb, and rough height will be here 12 inch here. Okay. Now come on the volume. Volume of this soil sample will be 1 by 30 feet cubic centimeter, or will be, which will be equal to 944 centimeter cube. Diameter will be 4 or 10.6 centimeter. Height will be 4.584. Okay, now come on the equipment needed for the compaction. As you can see here, first one is given standard proctor mold, which is required one piece. Standard proctor mold, one piece. Standard proctor hammer will be required one piece. Extruder will be required one set, and square pan will be required one set. Thin box Tin box will be required 12 pieces. Graduated cylinder will be required one piece. Scoop will require one piece, and trowel will be required also one piece. And these are the equipments which is needed for the doing the compaction of a soil. The soil standard proctor test. The soil is mixed with the varying amount of water to achieve different water content. For each water content, the soil is compacted by the dropping a hammer 25 times into the confined soil. The soil is mold will be dividing into three lift. Each lift is compacted 25 times, and we can also say each soil will be divided into three layer, and each layer will be compacted 25 times. This is the done 4 or 2 6 times, and this will be the pattern of doing the compaction here. Now, what is the standard energy? Standard energy is the also factor which involve in the compaction of a soil. Competitive applied to the soil per unit volume will be equal to blows by layer, or number of layer, hammer weight into hammer drop on volume of mold, and ESP will be equal to 25 per layer, 3 into 3 of layer into 5.5 lbs into 1 feet, and 1 will be divided by 30 feet cubic feet, and it will be equal to 12,375 feet lbs per. Result for the standard proctor test. When you will do the standard proctor test, you have to plot diagram like this. As you can see here, there is a maximum dry unit weight, and that is your maximum water content, and optionally the confined compressive strength of a soil also measured. A sample from the mold, as you can see here, this is the graph which we have to plot during the compaction by the standard proctor test. Now we will see the Proctor principle of a compaction using a standard energy. If a series of specimens of soil are compacted at increasing water content, the result dry density of a specimen will be vary. The density will be increased to a peak value, then decrease. So you can understand what we have to do. We have to use the water content in a variation, and when we will get the maximum density, then we have to stop it, and on that point we will get our MMD, which is known as maximum dry density, and after that your density will be decreased as mentioned here. Principle of compaction: a plot of a dry intensity versus uh, the water content from the compaction test will be parabolic in its shape. The peak of curve is termed the maximum dry density, as I told you, MDD, and the water content, which is peak occur in the optimum water content, which is known as OWC. And here, several standard energies are used for the laboratory of compaction test. First one is the standard, modified, and California. And there is a different value of energies which involve in the doing the compaction of a soil. Now we will see the summary of a standard Proctor test here. As you can see, there that is your hammer, which have weight of 5.5 kg, and there is also drop distance which is given here 12 feet, and uses 5.5 pound hammer, drop 12-inch mold filled in the 3 lift, 25 blows of hammer per lift. Total energy will be consumed here, as you can see, 12,400 feet lbs per feet cubic feet. And here, as you can see here, that is the same thing. Now we will come on the several standard molds are used depending on the maximum particle size sample. 4-inch diameter mold, which is equal to 1 by 30 feet cubic, used for the low gravel content method. A soil which will be less than 20% of gravel. Method B of soil, where it will be greater than 20% of gravel and 20% larger than the 3 by 8 inch. And several standard mold are used, as you know, for the compaction of a soil. Standardized tests are not available for the soil with more than 30% by the weight of the total sample being larger than 3 by 4 inch in the diameter gravel. ASTM compaction test method are also given here, which is mentioned as here. There is 6 method of ASTM compaction test. And now come on the how you have to do the test of the compaction Proctor test. First, you have to prepare a 4 to 5 specimen at the increasing water content about the 2% apart. Example, prepared is simple at 14, 16, 18, and 20%. Use range of moisture based on the feel and experience. Like here, as you can see here, you have to use the water content in the soil. Like first you have to use the 14%, after that you have to use 16, 18, 20, and you have to repeat this. You have to repeat this percentage of water in the soil till you are not getting your maximum dry density. Here you can see Proctor compaction test summary. Hammer then compacted each sample into the steel mold with the standard procedure, and cured soil is also here, and compacted mold is also here. Now we will see the what will be the next. Then strike of axis soil so that mold has known as volume of the soil. As you can see here, we have to strike off the axis amount of soil from this mold so that we can get the exact volume of a soil. Here, as you can see here, laboratory method of determining optimum moisture content and maximum dry density. As you can see, this is your image of mold and standard Proctor mold with the hammer. And here is the method which is invented by the R. Proctor in 1933, which is, as you can see here, your soil layer is divided into 3 parts, and this is there we have to use 2.kg hammer, and each layer we have to give the 25 blows of a hammer. And now, what we have to do in Proctor compaction test summary, we will see here. For each sample, measure the weight and the water content of the soil in the mold. The mold volume and weight are pre-measured. Don't assume nominal volume 1 by 30 cubic feet and 1 by 13.33 cubic feet. Calculate the density, calculate the dry density, plot dry density and water content for each point. As you can see here, what is the problem? Calculate the moist density and dry density. This will be the formula which we will use during the calculation of the moist soil weight of a soil. As you can see here, this is your formula. And now we have to see the dry unit weight. The compacted soil is removed from the mold and its dry density or unit, which is also known as dry unit weight, is measured by gamma m upon 1 plus w, which is, as you can see, gamma d is equals to dry unit weight, and w will be the water content, v will be the total volume of soil, and m will be the total mass of the wet soil, and g will be the gravitational acceleration. As you can see here, by the here mg upon v, we have to put the data in this formula. We will get the dry unit weight of that soil. And now we will see what is the role of water in the compaction process. Water lubricate the soil grains so that they slide more easily over each other and can thus achieve the more density packed arrangement. A little bit of the water facilitate the compaction. Too much water inhibited compaction. As you can see here, this is your dry unit weight graph where we have to use the soil and we have to do the density. And here is the modified Proctor test was developed. And now we will come on the modified Proctor test. We have done standard Proctor test. It was developed during the World War II by the US Army Crops Engineering for a better representation of the compaction required airfield to support the heavy craft, as you can see here. And in modified Proctor test, same the standard Proctor test of the following exceptions. This is the soil compacted in the 5 layer, and there will be weight of hammer will be 10 lbs, and there is a drop height will be 8 inches. That is the difference between modified Proctor test and standard Proctor test. And this is the graph of a modified Proctor test and standard Proctor test. You can see here. Now we will see the comparison summary of standard Proctor test and modified Proctor test. Mold size will be 1 by 30 cubic feet, and here will be 1 by 30 cubic feet. 12 in the height of drop. Here will be the mold height of drop, which is 18 is given. 5.5 lb hammer, and there will be the weight of hammer will be also more in the modified Proctor test, and there will be 3 layer in standard Proctor test, and there will be 5 layer. And this is the difference, which is very important to know. What is the difference between standard Proctor test and modified Proctor test? Now you can see this is your curve will be which you will get in the during the compaction of a soil. Now we will see what is the zero air voids. As you can see here, that is the figure which is showing the dry density and water content relationship, and this is also known as degree of saturation graph. And JAW, as you can see here, which is known as zero air voids. The curve represents the fully saturated condition, which will be where S will be equal to 100%, and JAV cannot be reached by the compaction. Line of optimum, as you can see here, there is one line of optimum, a line drawn through the peak points of the several compaction curve at the different comparative effort for the same soil will be almost parallel to the 100% S curve. And there is also entrapped air, as you can see here in the graph, entrapped air. It is the distance between the wet side of the compaction curve and the line of the 100% saturation. Now we will see the results. What will be the results in the dry of optimum? As the water content increase, the particle develop larger and larger water films around them, which tend lubricate the particle and make them easier to be moved about and reoriented into a denser configuration. Here is also hammer impact. It is air expelled from the soil upon the impact quantity is larger than the volume of water added. And here is also weight of optimum. What is the meaning of weight of optimum here? And water, when our water start to replace the soil particle in the mold, and since the rho will be less than ps, and the dry density start to decrease. Hammer impact, what is the hammer impact? Moisture cannot escape under the impact of the hammer. Instead, the entrapped air is the energized and lift the soil in the region around the hammer. So these are the result explanation of a compaction. As you can see here, that is your OMC, and this is your dry side, and this will be your wet side. Means this will be your soil in the dry condition, and this soil will be in the wet condition, as you can see. Now we will see the effect of soil types on the compaction. What will be the effect of soil type on the compaction? The soil type, that is grain size distribution, shape of the soil grain, specified of soil solids, and amount of type of clay mineral present. As here you can see the compaction characteristics. What is the meaning of the compaction characteristics? We will see here unified soil classification, where is a group symbol GW, GP, GW, GC, SW, SP, SM, which will be the meaning of these types of soil will be good characteristics, have a good characteristics of compaction, and SCCL, which is good and fair, and ML good to poor, and OL, MSCH, OSPT fair to poor. And we will see the embankment material. What is the which soil will be good for the embankment of the, like embankment of the wall, embankment of the dam? You can see GWSW will be very stable, CL will be stable, but it will be not like GW and SW. GP, GM, GC, and SC reasonably stable. It will be not as good as the CL. SPSM reasonably stable when dense. ML poor gets better when high density, and OH, MHCHO, PT, that are the unstable and poor, and you cannot use this soil for the embankment preparation. And here we will see subgrade material, which is subgrade material means this kind of soil used in the construction of subbase of a road construction or road pavement. As you can see, GW will be the excellent, GPGM will be the excellent to good, GCSW will be good, SPSM, SC will be good to fair, MLCL will be fair to poor, and OL, MHCH, OHPT will be poor to not suitable. It is not suitable material which we can use for this preparation of a subgrade. Now you can see the typical compaction curve for cohesionless sand and sandy gravel. This is the graph which is showing the bulking capacity of a sand and sandy gravel. The low density that is attainable at the low water content is due to the capillary forces resting arrangement of the sand grains. Now we will see water and compaction. What is the relation between water and compaction? Remember, what is the effect? What is the effect of water in the compaction? First, we will see here increasing the water content at which the soil compacted increases the likelihood of obtaining disparate soil structure with the reduced shear strength. Increase the pore pressure in the soil, decreasing in the short term shear strength. So you can understand this is the relationship between water and compaction, and here you can see how water can affect the compaction of a soil. Here you can see this is your graph which is showing the structure of compacted clay. As you can see here, there is flocculent soil, intermediate structure, and disparate structure. By the compaction, we can increase the shear strength of a soil. This means the larger load can be applied to the compacted soil since they are typically stronger. And it also reduces the permeability. This is the inhabit soil ability to absorb water and therefore reduce the tendency of expand, shrink, and potentially liquefy. Reduce compressibility. It also reduces the compressibility. It also controls the swelling and shrinkage, and it's also reduce the liquefaction. As you can see, there is various compaction types test. As you can see here, there is types of test like mold, hammer, mass, drop, number of layer, blows a layer. This is the table content of various types of compaction test. As you can see here. Now we will come on the general compaction method for the coarse grained soil and fine grained soil. Here one is the laboratory test and one is the field test. And in laboratory we have to use vibrating hammer, which is known as BS. And for fine grained soil we have to use the falling weight and hammer, kneading compactor and static load and press. Here you can see in the field we have to use the hand operated vibrator plates, motorized vibrator roller, rubber tire equipment, free falling, compaction vibration, weight and dynamic frequency we can use, and hand operated temper we can also use for the field, uh, and seafoot roller, which is used in the compaction of soil. Rubber tire roll, this is also used for the soil compaction. And standard proctor test, first we will see the standard proctor test, how we will conduct the standard proctor test. As you can see, R.R. Proctor in the early 90s was building dam for the old Bureau of Water Work and Supply in the Los Angeles. And he developed the principle of compaction in series of articles in engineering news record. And variables of compaction is here also. Proctor stabilized that the compaction is the function of four variables, as you can see here. First one is dry density, which is represented by the gamma D, or dry density unit weight, which will be represented by the and gamma D also. And water content W, comparative efforts energy E, and soil type gradation, presence of clay and minerals. These are the variation which affect the compaction, and these are the, you can also say this is the compaction function for the variables. Now we will see the compaction proctor test here. Standard proctor test equipment. There is hammer, which weight is 5.5 lb, and rough height will be here 12 inch here. Okay. Now come on the volume. Volume of this soil sample will be 1 by 30 feet cubic centimeter, or will be, which will be equal to 944 centimeter cube. Diameter will be 4 or 10.6 centimeter. Height will be 4.584. Okay, now come on the equipment needed for the compaction. As you can see here, first one is given standard proctor mold, which is required one piece. Standard proctor mold, one piece. Standard proctor hammer will be required one piece. Extruder will be required one set, and square pan will be required one set. Thin box Tin box will be required 12 pieces. Graduated cylinder will be required one piece. Scoop will require one piece. And trowel will be required also one piece. And these are the equipments which is needed for the doing the compaction of a soil. The soil standard proctor test. The soil is mixed with the varying amount of water to achieve different water content. For each water content, the soil is compacted by the dropping a hammer 25 times into the confined soil. The soil is mold will be dividing into three lift. Each lift is compacted 25 times, and we can also say each soil will be divided into three layer, and each layer will be compacted 25 times. This is the done 4 or 2 6 times, and this will be the pattern of doing the compaction here. Now, what is the standard energy? Standard energy is the also factor which involve in the compaction of a soil. Competitive applied to the soil per unit volume will be equal to blows by layer, or number of layer, hammer weight into hammer drop on volume of mold, and ESP will be equal to 25 per layer, 3 into 3 of layer into 5.5 lbs into 1 feet, and 1 will be divided by 30 feet cubic feet, and it will be equal to 12,375 feet lbs per. Effect of the compaction on permeability. This graph is showing the effect of the compaction on the permeability. Permeability at constant compaction effort decrease when increased water content and reaches at a maximum and minimum at about the optimum. If compactive efforts is the increase, the permeability decrease because the voids ratio decrease. This is the graph which is showing relationship between water content and density and water content and permeability. Now we can see here this is the effect of compressibility due to the uh, pressure which we use during the compaction and magnitude. Wet side more compressible in low pressure range, dry side is a high pressure range. And what will be the rate? Dry side consolidation will be more rapidly. As you can see, these are the two graphs which is showing relation between pressure and natural scale and void ratio. And this is also for the low pressure consolidation, and this one is for the high pressure consolidation. This graph is showing. Now we will see the compressibility and expansion of a unified soil classification. Here is a group symbol which is also showing the compressibility and expansion of these soil. As you can see here, and these five soil will give the very little, and this is very slight, and this will be slight to medium and medium to high. And this is also the group symbol which is showing the compressibility and expansion relationship of a soil. Now you can see here what will be the effect on the strength. Simple kaolinite compacted dry of a optimum tend to be more rigid and stronger than the simple compacted wet of optimum. And this is your comparison of soil particle properties, dry of optimum and weight of optimum compaction. As you can see here, if there will be undrained and drained soil, dry side much higher and dry side is some lower higher strength. So you can see here how the soil type can affect on the strength of a soil. What is the effect of swelling? This is also very important point of a soil. Swelling of compacted clay is greater for those compacted dry optimum. They have a relativity greater deficiency of water and therefore have a greater tendency to absorb water and thus swell more. As you can see here, this is the graph which is showing dry side, wet side, and which is showing the higher swelling potential and higher shrinkage potential. As you can see in this graph, this is your OMC, which is known as optimum moisture content. Now compaction and shrinkage, we will see this graph is showing the sample compacted weight of optimum have the higher shrinkage, as you can see in your figure. Now this is the method of preparing summary. By this method you can prepare the summary of compaction of the soil. As you can see here, there is UCS group symbol and compaction characteristics, compressibility and expansion, value of embankment material, value as the subgrade material. Now there is some appendix which we took from the IS code. As you can see here, that is the comparison of soil properties between dry of optimum and wet of optimum compaction. Now we will see here compaction of a earth dam, how it can be possible and how it will be affected on the earth dam. The engineer must consider not only the behavior of soil as the compacted, but the behavior of soil in the complete structure, especially at the time when stability or deformation of structure is most critical. For example, consider an element of compaction in a dam core. As the height of dam increase, the total stress of soil element increase when dam is performing its intent function of retaining water. The percentage of saturation of compacted soil element is increased by the permeating water. Thus, the engineer designing the earth dam must consider not only the strength and compressibility of the soil element as the compacted, but also the properties after it has been subjected to increase the total stress and saturated by the permeating water. So you can understand how uh, the compaction plays very important role in the earth dam. Whenever you are doing doing the compaction or for the earth dam, you have to not only consider the dry unit weight and the water compaction, you have to also think about the permeability and how the total stress work on that soil. So this is a very important consideration which we need to do during the compaction of a earth dam. Now we will see the field compaction equipment and procedure, and there is also some objective of a field compaction and control parameter. The objective of compaction is to be stabilize soil and improve their engineering behavior. As you can see here, the important keep in mind desired engineering properties and field dam road. The density of field addition to the water content should be observed. So these are the objective which we have to take care during the compaction of this kind of soil. Now come on the compaction field, which is compaction field equipment, which is very important. As you can see here, this is your wheel road drum, which is 100% coverage under the wheel, contact pressure up to 380, and can be used for the all kind of soil and competitive efforts static weight. The most common use of large smooth wheel roller is for proof rolling and subgrade and compacting asphalt pavement. So these roller can be used for the all kind of soil which we take in the construction of a dam, which we also take in the use of construction of subgrade of a road pavement. And here, what why it is suitable, as you can see here, suitable for well graded sand and gravel, silt and clay of low plasticity. It is also suitable for the silt and clay which has very low plasticity, and it is also very suitable for well graded sand and gravel. And here is unsuitable for the ununiform sand, silty sand, and soft clay. Now come on the MCQs. We will see the MCQs from here, as you can see. Now we are coming on the MCQs, which we have to do after this class. Yes, here is the MCQ. First question is, soil is dry or of optimum as compared to that weight of the optimum. First option is given here, has less permeability, swell less and decrease less. Here will be the right answer. Here will be the right answer is shrinkage less. That will be your right answer. Come on the next question. The ratio of volume of voids to the total volume of solids will be known as volume of voids, degree of saturation, and air content porosity. Here right answer will be here. Porosity will be your right answer. The soil which plot above a line and plasticity chart are, there is four option is given. First one is clay, silt, sand and organic soil. Here right answer will be your clay. Clay will be your right answer, as you can see here. So you can understand here how to plot a line, which is very important in the plasticity chart. So a line will always show the clay. Come on the next question. If the classification of soil in many respects similar to Astho classification, textural classification, unified soil classification, MIT classification. Here right answer will be your unified soil classification. That is the similar to all of these. As you know, unified classification, soil classification is also similar to. Here will be the right answer, unified soil classification. And now come on the next question. The following types of soil is glacier, deposited. There is four option is given: drift tail, outwash, and benotine. And here right answer will be benotine. Now come on the next question. Cohesionless soil are formed due to the weathering of a rock due to chemical reaction, blowing up the wind and ice, physical disintegration of rock, bleeding of rock by the organic acid and water. Here right answer will be physical disintegration of rock. Come on the next question. Standard penetration test is useful to measure shear strength of a soft clay, shear strength of a sand, consistency of a clay, none of the above. Here right answer will be shear strength of a sand. Now come on the next question. Dry density of soil is equal to mass of solid to the volume of solid, mass of solid to the total volume of solid. Density of soil is desired condition, none of the above. Here right answer will be mass of solid to the total volume of soil. That will be your right answer. Come on the next question. Colloidal soil, which is known as talus, are transported by the water, wind, gravity, and ice. Let's see what will be the right answer here. Right answer here is a gravity. At the shrinkage limit, the soil is dry, partially saturated. Saturated, none of the above. Here, right answer will be saturated. Now come on the next question. Coefficient of permeability of soil increase with the increase in temperature, increase with the decreased temperature, increase with the decrease with the unit weight of water, decrease with the increase in void ratio. Right answer will be increase with the increase in temperature. Now come on the reference. This is the reference of this lecture, and thank you for watching this video.